Now that we finished the 4 pillars of inference, we're going to spend the rest of the course focused on studying relationships. And Chapter 5 is specifically about comparing two proportions. So in this particular study, subjects were randomly assigned to receive one of 2 types of placebos. Everyone thought that the drug was some sort of pain reliever, but half of them were told that the drug had a regular price of $2.50 per pill, and the rest of them were told that it had a discounted price of only 10 cents per pill. Then the participants were given electric shocks to the wrists, so we've been learning about some kind of unpleasant studies lately, and the researchers recorded whether or not subjects reported a reduction in pain after taking the pill. So we're looking at just a binary, yes, there was pain reduction, no, there wasn't pain reduction. So we've organized the outcome of this study in a 2-way table of counts. And when they say 2, that refers to the fact that there are 2 variables here. So these happen to also be binary variables, meaning they only have 2 categories. But even if there were more categories, it would still be called a 2-way table. And the graph that we can use to look at this relationship is called a mosaic plot. There's actually several different kinds of graphs that you can use for the relationship between categorical data, but mosaic plots are by far my favorite. So first, let's look at the heights of the bars. So that's representing in each group how many people had reduction in their pain. So we're looking at sample proportions. Sorry, the table and the mosaic plot are in different order. But the proportion who had pain reduction in the regular price group was 35 out of 41. So 85%, 0.854, had pain reduction in that group. Whereas the proportion in the discounted group was 25 out of 41, which is 0.610. So as we learned in the previous chapter, because these proportions are not equal to each other, that means that there is an association between these variables. There is an association between, in this case, the price of the placebo, that's our explanatory variable, and pain reduction, which is our response variable. So association just means that knowing one variable helps you to predict the other. So in this case, knowing the price that they were told helps you predict whether or not their pain was reduced. So this is what's represented by the heights of the bars. The heights of the bars are showing what we call conditional proportions. So within each group, what proportion had each outcome. A mosaic plot actually gives you a little bit more information though, because the width of the bars is also important. So the width is showing the sample sizes in each group. So in this case, the bars are the same width just because the regular price and the discounted price had the same sample sizes, but it's not always the case, and so that can be really helpful. Also, because of, just length times width equals area, the area can be used to show the counts. So in one graph, you can quickly see how the proportions compare, but also how the counts compare. So we have a table, we have a mosaic plot. What about statistics to describe this type of data? So when we say a statistic, we mean one number that's going to summarize the whole sample. One thing that we can do is just calculate the difference of these proportions. So we could take the proportion who had pain relief in the regular price group minus the proportion in the discounted group, and that comes out to be 0.244. So to interpret this, we could say that the proportion who experienced pain relief, that's a lot to write, there's probably a faster way to write that, proportion who experienced pain relief was 0.244 lower when the placebo was discounted. And I'm just going to put that in quotes because obviously it was just sort of being told to them that it was a different price. And you could also turn this around. You could say that the proportion who experienced pain relief was 0.244 higher when it was regular price compared to the discounted price. Also, notice that I'm being really careful here to say the proportion was higher or the proportion was lower. What we don't want to do is talk in terms of percents here. So don't say, for example, 24% lower. That would have a different meaning, sort of implying that you're multiplying something. So we want to be really explicit that we're talking about proportions here. If we wanted to make multiplicative comparisons, we could calculate the relative risk. So here, instead of subtracting the two values, you're dividing them. So we can do 0.854 divided by 0.610, which comes out to be 1.4. That's the relative risk. So to interpret that, we would say that those who got the regular priced placebo, that was the numerator here, those who got the regular price placebo were 1.4 times as likely, again, we're being pretty precise with our language, 1.4 times as likely to experience pain relief. And I'm going to be explicit about what I'm comparing to, compared to the discounted pill. And again, I'll put discounted in quotes. It doesn't really matter which number you put on top and which number you put on the bottom. Maybe it's more common to put the larger number on top, but certainly you can do either way. You just want to make sure that your interpretation is consistent with your calculation. So these are all ways that we can describe the association in this sample. So we see that the conditional proportions are not the same. We can calculate the difference and interpret that number. We can calculate the relative risk and interpret that number. Let's also think about what would it look like if there were no association between the price of the placebo and pain reduction. So here I have what's called the marginal totals filled in, but I want you to think about what the counts would look like if there were no association. So pause the video here and see if you can figure out those counts. So there's definitely more than one way to think this through, but you may notice that 60 of the people in the sample experienced pain reduction. So if you think about it as like successes and failures, we have 60 successes and 22 failures here. And you also notice that the sample sizes are the same. So you have 41 out of 82, which is 1/2 in each group. Since the sample sizes are the same, if there were no association, then you would expect those that experience pain reduction to be evenly divided between the two groups, right? You would expect half of those people in each group. So we would do half, which I'm going to write this as 41 out of 82, you'll see why in a second, times 60, right? So that's going to give me 30 who were in the regular group and had their pain reduced. And I could do that for every single category. I can also just subtract from the totals. Later we'll learn that this table has 1 degree of freedom, because if you put in one value here, that's enough information to calculate the rest. So I can subtract and get these numbers. But let's say I want a more general formula for these counts. So I'm going to rearrange just a little bit, but I think you'll see that it's the same. So I'm going to write it as 60 times 41 out of 82. In other words, I'm looking at the row total of 60, and I'm multiplying it times the column total, which is 41, and then I'm dividing that by the overall total, which is 82. And that formula altogether is what we call the expected counts. So when we say expected counts, we mean what would we expect if there were actually no association between these variables. So section 1 is all about descriptive statistics. That's what we've been doing in this example. We'll move on to inference in the next video.